Welcome to this presentation of Roboteq's Automated Guided Vehicle Simulator. A magnetic track-guided AGV can be built with just two Roboteq components: an MGS 1600 magnetic guide sensor and any Roboteq dual-channel motor controller. The sensor measures the distance to the center of the track. Using its built-in programming language, the controller takes this data and computes the power to apply to the left and right motor needed for the robot to stay on track. The simulator lets you write the navigation program, then test and fine-tune it in the comfort of your PC. The simulator opens with the image of a mobile robot on the screen. We can load a track. Here we have a simple track with a couple of forks and location markers. Markers are pieces of tape of opposite magnetic polarity from the track. We move the robot to the desired start position and orientation. Then, load the controller's navigation program and click on the Run button. Our robot starts moving. We can zoom and pan over the track. Notice how the sensor captures the markers when the AGV moves over them. Notice also how the sensor can capture two tracks at forks and merges. The AGV moves according to its actual physical characteristics: wheelbase, gear ratio, wheel diameter, and sensor distance from the pivot point. The console shows monitoring data from user print statements inside the program. The AGV will stop when both a left and right marker are present. In the real AGV, a button connected to one of the controller's digital inputs is used to resume motion. The controller's inputs and outputs are also simulated. Clicking on Input 1 makes the robot go again. Let's now make a few changes. We will edit the track to add a charging station. To make it more challenging, the robot will pivot from the main track and get on the new track. We add two markers at the charger's stop point. We save our track. We now open the source code to edit it. The rotation sequence starts when the AGV is at a stop point and input 2 is active. The robot will rotate for 2 seconds without looking at the sensor, then continue to rotate until a track is detected. Then it will get back in line-following mode. We check the code to make sure there are no errors, and close. We position the robot near the stop point, since this is what we want to test. And run. We activate Input 2 to indicate a low battery condition. The robot stops. Oops, the robot moves in the wrong direction. We open the editor again. Change the sign of the steering command. Run again. All is good. Details on how to build automatic guided vehicles using Roboteq sensors and controllers can be found on roboteq.com/AGV. Thank you for your attention.